Anyway, thank you for coming my presentations. I'm Megumi from Tokyo. I work at the Bay Network. You may know Bay stack switching, hub, and axial routers in those days, 1980, 1990s. And I worked also notable as a system engineers and IS staff. But company is declining, so I started a small business as a network service, kind of package things. I'm very lucky because in 2008, I'm one of the reseller of Case Technologies in those days with Gerald Sands and other core developers. They create Israel, then changed to Wireshark. So I'm lucky to join the Wireshark ecosystems. Now, I love packet analysis, so I wrote 10 more books about Wireshark and packet analysis, but all in Japanese. And I instruct Wireshark to Japan's self-defense forces and other companies. And I'm also a reseller of some kind of capture devices like ProFshark, Dragon, tabs, and so on. And I'm one small contributor of Wireshark, open Wireshark, set preference, and change language to Japanese. Now, Wireshark says Japanese. Now I'm back, go back to original one. So, and you can see my name in Chinese characters like Megumi, like this. It's my Chinese character's name here. Anyway, I talk about this here, dissecting audio and video protocol using Wireshark. There is 5 cases using Wireshark to dissect typical audio and video protocol now. First one is live or on-demand streaming using RTMP, technology by Adobe, famous for flash video. Next one is somehow today's protocols, HTTP live streaming made by Apple. People say as HLS and transferring MPEG-2 files, .ts extensions. And next one is typical voice over IP protocols. And another one is surveillance camera. Somehow interesting, we have to change port or something. And last one is a non-drive recorder. In this case, we have to assume port numbers, protocols, and codec, and use RTP dump and FFmpeg tools. If you are interested in all PDF and trace file and tools are here. I zoom in, this address, www.iknjp SharkFest. You can download my stuff, this address. At first, we start with flash video things. There are many live or on-demand video service in today's internet. For example, YouTube, Facebook, TikTok. Of course, in Japan, Nico Nico Movies and other many services. They use RTMP, real-time messaging protocols for broadcasting. RTMP is derived from Adobe, a former Macromedia. Someone may remember Macromedia company, and Flash Player use them. And we can download the protocol spec at Adobe homepage. This one is. We can download the PDF information of protocol spec. It is also proprietary protocols, but specification is published. And there are many types of RTMP. Plain RTMP use TCP port 1935, but we use web browser to watch the video. So mainly use RTMP tunnel is used for browser. And RTMPS is HTTPS uses HTTPS to encrypt RTMP. Is known as RTMP over tiers. And there is another UDP version of RTMPS. I mean, many words. Some web service uses different port numbers. In those cases, try heuristic sub-dissectors first in TCP UDP preference or manually set decoders. I show this open preference sheet and protocols and choose UDP and try heuristic sub-dissector first. And also same things in TCP preference screens. If we check these options, Wireshark try to look for which application protocol is good for dissecting, and they may choose right one. But if it fails, we can set manually to assign port numbers as decoders. Just like this, open some packet and right click to preference sheet, protocol preference, or right click to protocol preference and go to UDP or TCP and check this field. Try heuristic sub-dissectors first. Wireshark can look for adequate application protocols for dissecting. Nice functions, I think. Next one. First, start capturing using dump cap -i interface numbers and set -f to capture filter and write out the RTMP.pcapng. Then start streaming to open this address, fms.105net live RMC by VLC player. Then stop capturing and open trace files. In this case, please take care. We have to capture it first, then open VLC player. Because connection packet can exchange first time, so we have to capture all frames. I try this. Set command like this and start capturing, and next open VLC player to open network streams and set the address as fms.105net live RMC 1 like this, connect internet. It's some kind of music channels. I stop this and Control C to stop the stream and open trace files rtmp.pcapng, this file like this, and set display filter as RTMPT. It's interesting because former internet, there are AppleTalk family protocols, routing, maybe former AppleTalk protocol use the same name. So Wireshark dissector, you use RTMPT to filter packet. Sorry. Next one. Wireshark use RTMPT display filter string because RTMP is already used for routing table maintenance protocols. So all the protocols, all AppleTalk protocol families. So set display filter and check the start 3 packet. RTMP exchanges 3 packets for handshake after TCP connection is created. They change just timestamping and confirmation for connecting. Like that, open trace file and set display filter as RTMPT and check info sequence. handshake, handshake, handshake. So start streaming. And next, connection start of RTMP, like 14 packet. Client sends action message format message using connect server with address. We can easily find the URL of contents. If you may know, some broadcasting video or some on-demand video conceals actual locations of contents. But if you use Wireshark, you can easily, the contents is here. You can record the secret video or something to your hard disk. Just check that. Check connect frames, transmission protocol port 9035, and open real-time message protocols, and check headers and string connect, and check object. Here is the locations of content. This time I know these strings, but sometimes it's concealed. So Wireshark is good tools for finding the locations of streaming. Then next one. And then server responds with window arc size, bandwidth, stream informations, and chunk size, and result connection succeeded, like this. And then client creates a stream and server responds with result. Client sends play message to play RMC1. This is the actual content name of streams, and server responds with result, and server starts playing the stream, like this. After connections, client send connect with the locations of actual places, and then set window size, chunk size, and connection succeed. We got connection succeed message, and then play this string. This is the content name RMC1. If streaming information is concealed, Wireshark can easily find the locations and the file name of the content easily. And then many chunk data come to 9065 port. There are many channels at a time. We can use audio and video and other media at a time. Stream is divided by each chunk stream ID, and small size sent by each chunk stream ID. And RTMP body contains type and codec. And first player receives them and plays stream smoothly. Like this, I check the actual packet, and after connection succeeded, send stream data. There maybe contains videos and audio at a time. Some packet contains audio and video at the same time. This one, audio and video, audio. So check the RTMP headers and RTMP body. Someone has a chunk stream ID 6 is audio data, and chunk stream ID 5 is audio, and codec is AC, and chunk stream ID 6 is audio, AC, and some cases, this time it's just only audio, but some other packet contains this one, chunk stream ID 7. Chunk stream ID 7 contains video data using H.264. We can collect each chunk data using Wireshark. So if you want to check actual streaming, RTMP dump is useful tools when you save video to FLV format. This is open source tools, RTMP dump, employerhq.hu is a URLs. This time we use Windows versions of RTMP dump. We got the stream information from packet 14 contains the locations and packet 23 contains the file name. Then start RTMP dump with small r options to read the stream places and small o option to output flash video. Let's try that. RTMP dump. RTMP dump. Okay. Just cut and paste this word and do this. Connecting using RTMP and changing 3 handshake and create streams and stream started and we got the stream informations to out.flv. Maybe this file. Open this file with VLC player. Open this. Play again. We can play stream information from check actual streams using Wireshark like this. Collecting locations and the name of contents from Wireshark trace, and you can save lives or on-demand streamings to your PC. Then you can change format from FLV to MPEG and other format. But FLV is somehow old urban. Of course, flash video is still used in some web service, some kind of adult one or something. But nowadays, people tend to use next versions of streaming because there are many vulnerabilities in flash players. So we live in HTML5 generations. Apple may not like Adobe, so iPhone, iPad, of course Microsoft Edge use HLS. HLS is as known as HTTP live streaming. They use just HTTP mechanisms to download content. Very simple, but so convenient because HTTP can through many firewalls and can through many NAT and other. They can easily tunnel by other protocols. HTTP live streaming divides the stream into small HTTP file downloads. M3U8 extensions is used for sending stream and bitrate list. And browser gets the playlist and checks the link of TS files, so they get this TS file, get this TS file, and get TS file. And HLS also support HTTPS too. So nowadays, HLS used many smartphone streaming or smartphone live streaming services. HLS mechanism is so simple. Distributor creates multiple MPEG-2 files, maybe about 10 seconds, and divide it using streaming segmenter or file segmenter. And do you remember, it's my Rio, Diamond Rio. There are playlists to many MP3 files, so I create the list of playlists to listen the music. It's the same. M3U8 means M3 playlist with UTF-8. So M3U8 is a kind of playlist. It contains many chunks of TS files, and the link is connected to actual 10 seconds MPEG-2 files. So client at first get M3U8 files and choose best one for good bitrate or good conditions, and play chunked TS files via HTTP in good bitrate. Let's test network camera live streaming. Some network cameras support HLS, so we try Unifor's network camera, maybe in Taiwan. Use dump cap and sets interface options and filter options to collect packet to trace file name is hs.pcapng. And it's important to open live stream with Microsoft Edge or Safari or VoIP player. Chrome and Firefox may not work well. I try this at first. Start capture with dump cap command. Dump cap interface and HTTP live streaming pcapng. And if you need filter, just port 80 or something and start capturing and open this playlist address using Microsoft Edge browser. Opening Edge browsers and open this URL. Wait for a second. HTTP connection start TCP three-way handshake and get HTTP playlist returns and get more good alternative playlist requests and alternative playlist returns. It contains tons of TS file by 10 seconds and get 10 seconds MPEG video and then get 10 seconds MPEG video. We can see MPEG streams like this. It's very common in iPhone and iPad and Microsoft devices. Open trace file and set display filter as HTTP and set statistics for graph. Open trace file like this. HTTP live streaming and set filter HTTP or HTTP and check the info screen, gets first playlist returns and get another beta playlist returns. The playlist contains we need to check right click to follow stream for TCP stream. It contains many set of TS files, Maybe next stream, maybe next one. Stream 3 contains a list of TS file. This is a list of TS file. First, get 1-0.ts and next 1.1.ts, then get 1.2ts. It's a content phrase. We can get 10 seconds streaming each time using so simple mechanisms using HTTP. Like this, client request, playlist, and server response with bandwidth information and alternative playlist with better bitrate or something. And then client requests the better alternative playlist and server responds many links of TS files. So browser start streaming like this. And finally, the browser gets the actual TS files and it contains the MPEG-2 stream data. So player can play the streaming. In this case, MPEG dump Lua script is a nice tool. There are many useful scripts, plugins, and dissector to extend Wireshark functions at the wiki page of Wireshark. MPEG dump Lua by Ryan-san is useful Lua script. They can remove all useless things, network headers, data link headers, and other headers, and just collect the media information. MPEG, just output MPEG2 streams. I try this. Download this Lua script from website, save in Wireshark home directory, program files Wireshark as MPEG under packets under dump.lua. And we need to contain and start this Lua script, so we need to edit init Lua in the Wireshark home directory, and at the following line, do file MPEG under packets under dump.lua. It finished. There are tool menus and there are new menu items, dump MPEG TS packets. So easy. I show this. At first, download script, dump script, then open Wireshark global configurations and check dump Lua script, and then open init Lua to include this line. Do file MPEG under packets under dump.lua and start Wireshark with these configurations. Wireshark can show up tool menus. I open again. Sometimes I open again. I open again Wireshark and trace file, HLS, pcap NG, and check tools. Just wait for a while. I think global configuration may change. I need to change Japanese at first. Why? I try again. Just wait for a while. Copy MPEG packets dump.lua to global configurations and replace the file and edit init Lua to execute and open Wireshark again. There are tool menus including this script. I try again, just wait for a while. This one, and copy this one. Finally, init.lua initialized, and it contains a link of dump MPEGs like this. I need to change language setting back to English and check tools, and we can find dump MPEG TS packets. Very easy things. So open HLS trace files using Wireshark and set tools to dump MPEG to TS, and just set the location of contents. C username, desktop, and HTTP live streaming.ts file. Done. We can get the TS files of streams, maybe here, maybe this one. Open this file with Windows Media Player. We can retrieve a movie from trace files. Interesting. And next, I talk about another things. Open MPEG2 file using Windows Media Player. You can check streaming video quality from the trace file. And voice over IP is also famous audio and video protocols. And the VoIP is used widely. And SIP server is a kind of PBX in VoIP network, and media gateway is used for connecting formal phone system with IP network. Connection start with using SIP, session initiation protocol, but then actual audio and video streams are sent by RTP, real-time transport protocols, and RTCP is used for transmitting audio and video data. So we test this trace file VoIP.pcap-ng. We capture traffic using IP phone. This is my old cell phone number. And receiver is some kind of test address of SIP servers. And open VoIP.pcap-ng in Wireshark and choose telephony to voice over IP calls to show call. And choose calls and click flow. We can get a nice flow graph of session initiation protocols. SIP call starts with invite method, then receive response. 100 trying, 180 ringing, and 200 OK to connect other side. And voice data is sent by RTP, like this. Actual voice data sent. Codec is G.71U. And SIP call ends by method and receive 200 OK response to finish the connection. Quick invite and RTP packet. Let's try this. Open trace file, VoIP. It contains typical SIP connections, so choose telephony to voice call. We can find the talker and initial speaker and from address and to address and durations. And just click flow sequence to understand the flow of SIP protocols. Start with invite, 100 trying, 180 ringing. After connection is built up, actual streaming traffic is sent by RTP. Connection finished with by method and 200 OK. Next one. Session initiation protocol is very similar to HTTP. They have header and body like HTTP, body and headers. Each request and response have request line and response code and many headers. And RTP is used for sending many chunks of multimedia data. RTP packet contains payload type, sequence number, timestamp, and SSRC, synchronization source ID, means the ID of voice over IP, and payload of actual data. Let's check this. Open trace file. At first, we set display filter as SIP. At first, invite, we can find the invite message, register to SIP servers, and after registering, send invite message like this, captured by UDP. It contains request line and headers. It's my phone number and body. And actual media is sent by RTP protocol. RTP uses UDP to send audio and video data. It contains a payload type, sometimes contains a SSRC here, and sometimes contains actual media data. I look for another packet, maybe this one. It contains payload type is G.711, very common in voice over IP, and ID synchronization source ID is here, and it contains the actual payload chunk of multimedia things. And back to VoIP calls, click play stream to open RTP player. We can check RTP payloads graph with the symbol of lost jitter, long timestamp, and invert silence. We can also listen the quality of audio. I try this. Choose telephony to VoIP calls and choose one calls and play streams to it can show up many symbols of jitter, long timestamp, and invert things. And if I want to listen this, maybe sound is not good, but I speak Japanese word or something, and packet is so small, so cannot hear well. But we can actually anyway, we can hear the sound like this. And next, telephony and RTP stream, summarize RTP stream of media. And I recommend to shift click to both stream, forward and backward, and click analyze button. You can check both streams at a time, and you also check SSRC, delta, jitter, skew value displays the quality of VoIP and sequence errors and drift informations. And we can also save audio data as .au format. Let's try this. Open VoIP calls. VoIP calls here. And for sheet, this. Choose telephony to RTP streams and check forward and backward stream using shift click, and then push the analyze buttons. Wireshark can collect the nice information of forward and reverse information with nice graph of jitter, including jitter, skew values, and difference. And we also save contents by quick saves and forward or backward and audio data as .au format, like this, sound audio AU format. And we can hear the actual sound later using this one, Open VLC player. It's much better, but in Japanese word. Playing saved RTP audio using VLC player. VLC player is free and open source based player. We can hear some Japanese word in this way. And next one, we try surveillance camera. There are tons of surveillance camera in the world. We can access them via website. Do you know Insecam.com? Maybe famous website. Someone not intend to update on this basis. This site is very famous website introducing public open surveillance cameras. You can search cameras by manufacturers, countries, cities, and so on. Let's try this. Open web browser and try www.insecam.org. This site is so interesting. We can just push manufacturer, countries, place or cities or something. Let's try Japanese one. This one. We can find some surveillance camera. Someone is not intended to upload it. Now Tokyo is about 11 p.m. So everything is somehow dark, but we can access surveillance camera and open the config screens, soft block, and click again to open the configuration screens of each camera. It may take some, it may show up the camera configuration screens and we can see actual camera recording. Somehow, I think it is interesting site. Sometimes you can stealthily look many places, many cities, and many places. This time, we pick up a Canon surveillance camera at the parking lot in Nagano Prefecture in Japan. Access camera and capture packets and save trace file as Canon camera Nagano.pcap.mg file. And open trace file and select statistics to conversations. And check first with TCP or UDP tab. Look for port number that camera used. In many cases, IP camera and network camera is tend to use the same port for broadcasting or recording or something. This time we found TCP8081 is a camera port because the bytes is bigger than that. Maybe this is video, and this one maybe audio. I think so. This time the camera is HTTP, so try to decode TCP8081 as HTTP. So select packet and right click to choose decode as and set 8081 as HTTP. Try this. Open trace file, Canon camera Nagano. And at first, we need to assume which port number is used for streaming or broadcasting. So press statistics and conversations to display TCP and UDP and sort by packet size or sort by bytes numbers. And assume which port is used for videos. I think this is the answer. Port 8081 should be used for videos. After decided it, I tried to change quick transmission protocols and decode as and set 8081 is used as HTTP. HTTP. Like this, TCP8081 used as HTTP. Wireshark now decode TCP8081 as HTTP dissectors. So check 15 frame and open HTTP dissectors and select media type and right click to show packet for checking. Especially simple and old network camera uses motion JPEG technologies. They intervally request some graphics and connect them and look them as videos. I'll try this. Open 15 frames and check the informations. And Wireshark can nicely dissect the port 8081 as HTTP and then choose media type and right click and show bytes, show packet bytes. Oh, it's true. In actual, HTTP response contains just CGI, no extensions of video, but we can get this data because the header starts with FFD8, FFD8 is a famous driver of JPEG files. So if there are no extensions, but we can easily assume this must be HTTP. And then file to export object to export files, many files to camera folder on desktop. There are maybe 500 file lists grouped by host name, content type, size, file name. Create a folder and save all to save them. And change extension to JPEG. Let's try this. At first, file to export objects as HTTP and save all to new folder test. We create a new folder test to save all files. Now there are, it takes some time. Maybe finished. And then Wireshark saves tons of JPEG file informations to just wait a while. Wireshark saves tons of CGI files. So at first we need to change extensions. So let's do this with for loop command. Change the directory with test and right click to use for script for some variable in this folder, rename adding JPEG functions to set the JPEG functions like that. After changing file extensions, but there are many dots in file name. It's not good in Windows environment. So I try to change this for rename this as a multiple number of JPEG files. I try again, open test. There are many, maybe 3,000 files. So Control A to check them and right click to change them. But there are some needless information. Maybe image. The file name starts with image. So I think this file is not correct one. So shift click to delete the needless files and then rename the file. Wait for files, delete files. And Windows is easy to change the set of file name. Choose all files and right click to change names and set image. Easily change all names as sequentially, like this, very easy. And now we create movies. There are many tools to create a movie from multiple JPEG files. Commercial one is Adobe Premiere. Can read multiple number of JPEG files to create a video clip. And some open source tool like Virtual DAV, Cam Studio support to create movie. In this case, we use FFmpeg to create a movie. Open Explorer and click one of JPEG files and rename file name to all sequential file names using for loop. Maybe there are 114 files. I use the for loop to set rename the sequential numbers like this. I try this. There are maybe 114 files. So I start with 1 and set for loop. Counter start at 1 and increment 1 and finish 114. Rename all files to a new one. Try this. Someone not find the file, but someone, I think it may not work well. Image, I mistake the name. Image, and the effect image, camera, and the effect. It works. We can create a sequential numbered file of 112 JPEG files. Then it's time to use FFmpeg. FFmpeg is GPS tools for recording, converting and playing video and audio streams. This time we use Windows versions of FFmpeg. FFmpeg has tons of options, but this time I set the F option to set format as JPEG and use R option to set the 30 frames per second and use I option to source file set. And AM option means no audio, and V codec contains a video codec, and PIX format contains a picture format. Let's try this. Move to FFmpeg directory and this one. Right click to FFmpeg to camera file. Location is not correct. Change directory to test this times and try to test FFmpeg folders. FFmpeg folders and and right click to do this. FFmpeg and set format and FPS and file set and frame per second and so on. Maybe I mistake. Just add this mark to automatically connect each motion JPEG file into one movie. Finally, I get there are some warnings. Finally, we got the movie files as camera.mp4. So open camera.mp4 using VoIP player. Finally, we can get the unknown surveillance camera movie from trace file. Let's try this. MP4 file. Maybe camera. There is a test. There is a output MP4 file here. Camera.mp4 and open this file using VLC player. This time I use FPS is not correct, so cam moving somehow fast, but it works. Anyway, it works. We can get the motion JPEG from trace files. You may think this one is easy. Finally, there are just remain 20 minutes. We try last one. Unknown drive recorders. This may be interesting for you. Many drive recorders are made in China or Taiwan. They use Wi-Fi to connect smartphone apps to check the camera recordings. Let's dissect with Wireshark. And I know recorder IP is 192.168.1.1. And I test like this. A non-drive recorder uses this address, and viewer applications in my iPhone, IP address is 192.168.1.101, and open smartphone app to check the video. And then I collect packets using AirPick app. very old one, but I love to use one. This one, and Wireshark. Trace file is here, unknown drive recorder.pcap. The trace file contains traffic between unknown drive recorders and smartphone apps using Wi-Fi channels 9, MCS7, using 802.11n 20 MHz bandwidth. I open this file, unknown drive recorder.pcap. They contain the radio tap header because we use Wireshark, AirPCAP to capture this. So Wireshark create convenient header .11 radio information. They use 11n, channel 9, bandwidth 20 MHz. Then there are LC headers, IP header, UDP headers, and RTMP protocols. It's time difficult. If you camera use HTTP or other technologies, it is easy to dissect. But RTMP or sometimes Wireshark do not dissect correctly. It's difficult one. We try to retrieve this. What encoding tons of small packets? Open trace file, we can see many small files. Sometimes we need to decrypt the encryptions of WPA2, or sometimes we need to use SSL key file to decrypt the TLS SSL connections. Open small chunk with binary editors, or you just seeing Wireshark data pane. It is lucky if the chunk is one of graphic file format. We can use the same way of surveillance camera, but this time no. So port number is usually changed from original one. In this case, we think about RTP streams. So start with, we choose statistics and conversation to check UDP streams. In this case, there are tons of small packets, but I don't know this UDP port is correct or not. So start with press statistics and select conversations, or select endpoint and choose TCP or UDP tab. In this case, there are no TCP connections, so media data is sent by UDP. And in this case, sort by bytes and assume what port is used for video and what port is used for audio, and other may be used for controlling stream packet. This one is easy because DNS 53 port. So I assume port 6070 is including video data, and 6972 contains audio, and 6971 and 6973 is control data. Maybe. So let's start dissecting. Multimedia traffic is sent by a few streams, and audio and video streams are divided by 2 in usual. But some other complicated applications use multiple channels. But in this case, Wireshark finds stream like this. And this time, Wireshark automatically dissects port 6070 is real data transport protocol. Maybe someone remember real player by real, so old format. Maybe it is not correct, it may not correct. So port number usually changed. So it's time to determine what protocol they truly use. So I look again at the conversation dialogue, and which stream is sending audio, video, and assume 6070 must be video, and 6072 is for audio. Then 6070 is well-known port of real data transport, but now no one use real media, so it may not correct, and we can find the packet data are broken. Dissector says malformed packet, so we have to change dissector to other protocols. Well-known port is not always correct. Please check this. Choose one of RTP real data protocols. I already changed the right click to decoders. I remove the 6970. And sometimes we got this frame broken and malformed packet. It says dissector is not correct one. Real data transport is not actual dissectors. In this case, we try to change the code as to assume another protocols. In typical drive recorders and other multimedia devices using UDP, it is commonly used as a real-time transport protocols. So I set RTP and press OK to check packet. Oh, no malformed packet. It works. And next. It's time to assume protocols. The cheap drive recorder tends to use general protocols. They do not use their own proprietary protocols. So in this case, this device must use RTP. So use analyze to decoders to change port 6970 and 6972 as RTP, and maybe 6971 and 6973 is for real-time transport control protocols as default. It's a nice hint for determining which protocol we use. This time we succeeded to decode UDP stream as RTP. But it's not finished. Codec is another big problem to get nice streams. RTP type 96 means dynamic assignment of RFC 3551 by INA. So it's difficult to understand which codec this stream use. Unfortunately, there are few information to determine the codec because the drive recorder is a known device. We can find some information from RTP stream dialog. There are SSRC informations, and we can find sometimes payload type or something. And we also find codec information from RTP stream analysis and save format as AU, but in this case, not audio. Drive recorder contains video, so we can't use these functions. So it's try to use another way. Go back to RTP stream, select video stream, then press export to export in RTP dump format. It's interesting functions. We can collect RTP informations and remove needless header like Ethernet, IP, and UDP, and remove needless headers, and then just output the RTP media informations. But someone troubled with Windows 10 environment. Wireshark 3 cannot export well with RTP dump format. I tested it many times, but Wireshark 2.x works well, but Wireshark 3 do not work well. So I'll show you. I found all RTP stream. I want to export RTP stream. At first, choose telephony to VoIP calls. It's no data because it's not the SHIP and RTP audio format, and I don't know which codec they use. So choose telephony to RTP to show RTP streams. We can find them, but there are no payload type if payload type says G.711, it's easy to play, but unknown format, unknown codec, so it's very difficult. In this case, we use export buttons here to export stream informations as RTP dump format. But Wireshark 3 do not work well. They do not return data. I show you. Rewrite in RTP dump data, but open RTP dump data, unknown drive recorder .rtp dump contains not correct information. Let's say RTP play something. Anyway, I tried another one. I used old Wireshark to create RTP dump data. This one is using Wireshark to create stream information as RTP dump like this. Let's try this file. RTP dump is one of RTP tools to processing RTP data by Columbia University, open source tools. RTP dump parse and points RTP packets and generating output files suitable for RTP play and RTP send. RTP play playbacks RTP sessions by RTP dump. RTP send generates RTP packets by RTP dump or text format. RTP trans can translate formats and so on. So download RTP tools this time. We use RTP tools 1.18 binary files. I try RTP play to play my unknown drive recorders RTP dump files in local loopback interface. So RTP play with RAST option to set files as RTP dump 127.0.0.1/port number is 6970. We can send RTP video streams from trace file. Then we need to determine which codec we use. Let's try this. Open command prompt. Change directory with RTP dump and try to notice set the command like this, RTP play with key options and set file unknown drive recorder .rtp dump with local interface 6070 port. The packet sending. I can check them. Now Wireshark can capture loopback interface using npcap driver. So I check adapter for loopback traffic capture interface and capture traffic like this. Maybe we need to set the filter string as udp.port == 6970. Oh, no, just why? Maybe command, maybe stop 6970. Oh, maybe try again. I try again with choose the create interface. Adapter for loopback interface. Close all Wireshark and open it again. Okay. And choose loopback adapter and try to capture packet. No. I mistake wrong folder. RTP tools is locations, so I missed it. I'm somehow upset. So try again. We send my RTP dump data using RTP play tools like this, copying and pasting like this. RTP play start sending RTP dump files, and Wireshark can collect these stream informations. We set the udp.port = 6970. There are tons of stream files. We can play again from the trace files. Almost done. Rest 5 minutes. Then check RTP stream setting. Send RTP stream using RTP play and set capture filters, and we can capture at the local loopback interface and stream send correctly. And next time, finally, we need to assume codec. For example, we try most common BSD license protocol, VoIP by Google. RTP video needs SDP file. SDP contains the specifications of each streams. SDP means session description protocols, including codec information. Smartphone app knows the codec, so easy to replay and check recordings. But we have no idea, so let's start assume codec manually. Then create SDP file including assumed codec. If there are RTSP and other hint, we can use this. In this case, create the file like this, version and connection data and IP address, and set codec information like this, and save as vp8.sdp, and use FFmpeg to record the streams. FFmpeg can also listen streams and create movie too. Read setting from a non-drive recorder.sdp and capture RTP stream, then create MKV file. MKV file means the intermediations files including the video, like internal files of PS files. FFmpeg-v warning protocols, whitelist file UDP, RTP file is SDP, and small I option to set the SDP files and copy to TS and -c, copy Y, and then create the a non-drive recorder MKV. Command is somehow wrong, but we can listen the RTP streams from RTP play with RTP dump format and recording from trace file and create the MKV file like this. I demonstrate this. At first, playing is easy. Playing with this command, Ctrl+C to stop, and this can play streams like this, play streams. And recording, I try this prompt, Ctrl+C to stop, and set FFmpeg like this. Change directory to FFmpeg directories, and like this, set port numbers, IP address, and codec files. Like this time I use VP8 files, and try this. Start streams and start recordings at a time. Playing streams and start recordings at a time. Sometimes it works well, but they said sometimes codec is not correct. This I try this, but unfortunately, we can simulate unknown drive recorders and smartphone applications by sending, receiving packet. At first, start RTP stream using RTP play command, and then recording RTP video from streaming using FFmpeg command. But mismatch. For example, output file is here, MKV file. It is not correct one. Sometimes it is okay, but sometimes it is not good. In this case, I check this. Open FFmpeg files, and check. There are no MKV file. Open MKV files. Oh, it may okay, but sometimes there are no correct codec in sometimes. In those cases, change codec as H.264 to change the correct codec informations. Oh, finally, I use another codec to create internal files like this, playing RTP dump and recording using H.264 format. This time it is success. It made success. Some says warning, but it can create correct videos. Control C to stop and open these videos. Oh, nice, better than last one. Finally, we can get nice video from unknown drive recorders. Use H.264 encoding instead of VoIP this time, and output file may work well. Finally, we got the videos using VLC players. So let's use Wireshark for multimedia things. We need to configure SDP file and with adequate timing and FPS and other values to make a better quality. And we need audio. There are no audio, so we also need to do the same things for audio streams too. But anyway, Wireshark can retrieve videos and check the qualities, and we can find many things about multimedia things too. Wireshark is not only typical format analyzer, but Wireshark is also a useful audio and video capturing, decoding, processing tools. So let's use Wireshark. So thank you very much.